Dear colleagues, I would like to present our study towards the software solution for complexity minimization of business process models to improve understandability. It was prepared by me, Andrii Kopp, and my colleague Dmytro Orlovskyi. Together we represent National Technical University, Kharkiv Polytechnic Institute, Department of Software Engineering and Management Intelligent Technologies. So let's begin with the structure of this presentation. It includes motivation, explanation what is BPMN, business process model complexity matrix overview, explanation on the overall complexity evaluation, formal problem statement, optimization model proposed in this paper and proposed algorithm, as well as the software solution that implements the proposed approach, matrix calculation results, example of BPMN model analysis, and conclusion and future work. So let's begin with the motivation. Business process are sequences of events, activities, and decision-making points that bring values to the organization's customers. Business process modeling is basic business process management technique, which can be used to graphically represent organization's process to elaborate and improve them. Business process models, therefore, can be seen as a form of knowledge representation that is widely used in many sectors of economy and industry. The quality of process models is critical. Process analysts should design understandable, explicit, unambiguous, and error-free models. The less a business process model is complex, the more it's easy to understand this model and vice versa. So therefore, in this study, we aim at the understandability improvement of business process models by minimizing their complexity. What is BPMN? BPMN stands for Business Process Model and Notation, which is a de facto standard for business process modeling. It depicts workflows using such primitives as start events that show where a process begins, tasks and sub-process that show work units, intermediate events that show things that happen in an instance, gateways to show process branching and merging, and git events to show where a process finishes. As for business process model complexity metrics, most of them are originated from software engineering, from the metrics used to measure source code complexity and other characteristics. These are number of activities, joins, and splits that originate from lines of code metric, control flow complexity metric, whole state-based process complexity metric, interface complexity, cognitive complexity metric, coupling metric, also from software engineering, modularity, coefficient of network connectivity, and density metrics, also originated from graph theory. For the overall complexity evaluation, there are several approaches exist. The first approach is based on thresholds of business process model complexity metrics, for example, for number of activities, joins and splits, and control flow complexity. Each of these thresholds allow us to divide different metric values to distinguish low complexity models, moderate complexity models, and high complexity models. Another two approaches shown here are based on the total complexity metric. Second case here demonstrates basic overall complexity metric calculated using control flow complexity, size of a process model, and diameter of a process model. And the third case here demonstrates another approach, which uses weighted overall complexity metric with respective weights for the number of activities, joins, and splits, for the control flow complexity, and for coefficient of network connectivity metric. So to provide the formal problem statement, we formulate the following linear programming model for complexity minimization of business process models, where x1, x2, x3, and x4 and x5 represent comprehensibility coefficients. And there are also respective weights used for each of these metrics based on their priorities. Using these comprehensibility coefficients, we can define, by solving this linear programming task, we can find complexity drivers. Each of these drivers represent the weak spots based on the respective metric. So the optimization model we propose can be interpreted as the minimization of weighted squares of distances between actual complexity metric values and lower bounds of these metric values that correspond to the moderate understandability of process models to find comprehensibility coefficients x1, x2, x3, x4, and x5. And the proposed algorithm demonstrates how we can process business process models to first calculate metrics of the control flow complexity separately for XOR splits or exclusive OR splits, inclusive OR splits for control flow complexity, and control flow complexity for parallel splits or AND splits. Then it's necessary to calculate number of activities, joins, and splits metric. Then calculate coefficient of network complexity metric, and check if one of this metric is greater than its lower bound. Then find comprehensibility coefficients x1, x2, x3, x4, and x5, and to define complexity drivers to make a decision which is the weak spot of model that makes it inefficient in terms of its comprehensibility and understandability. Then calculated results should be saved for further processing. And we have implemented the proposed approach as the Python program, which takes a collection of BPMN 2.0 files as input and reads these XML-like documents and stores the obtained results into comma-separated values document for subsequent analytical process. The analytical processing then is done using Microsoft Power BI tool. So the metric calculation results here demonstrate different values calculated for 10 business process models given in BPMN notation, calculated for these 5 metrics: CNC, coefficient of network complexity, CFC of 3 different types of gateways, the control flow complexity, and size or number of arcs of activities, joins, and splits. And here we can see the hardest BPMN models for comprehension, which are the first model shown in the orange color, third model shown in the yellow color, fourth model shown using blue color, and they are all here represented as deviations within different metrics and within different models. And there are, on the second picture, there are also 8 model in yellow color and 9 model in blue color, also shown as the hardest BPMN models for comprehension. So as the example of BPMN model analysis, we have used these business process models of goods dispatch process that takes place in a small hardware company. Using this BPMN model and the proposed optimization model, we have defined comprehensibility coefficients for each of considered metrics and respective complexity drivers. So here for the complexity coefficients, we have 2 highest values for size and network-based comprehensibility. And respectively, we got the following complexity drivers, demonstrating that this particular business process model is not efficient because of gateway splits of all of the three types, XOR, OR, and the AND, because they have the highest values for complexity drivers. And therefore, this matrix can be used as a recommendation to review the correctness and understandability of this business process model, redesign it, and pass under the next stage of review. So to conclude, the existing business process model complexity metrics were analyzed, and we proposed the optimization problem to minimize complexity of BPMN 2.0 process models. The algorithm and the software for evaluation of process models comprehensibility are proposed, and we got the following findings. Business process models given as BPMN 2.0 files are easily processed as machine-readable documents, and they can be used as human-computer interface to share process knowledge. And with the relatively close coefficient of network complexity values, values of size and control flow complexity metrics could significantly vary, causing negative effects on the business process model understandability. And found comprehensibility coefficients and related complexity drivers reveal weak sides of business process models and could be used as subjects for improvement recommendations. In future, this approach can be extended with intelligent technologies using machine learning methods or neural networks to define comprehensibility coefficients, as well as big data technology can be used to process large collections of BPMN models, because in large organizations they can have hundreds and thousands of models. Thank you very much for your attention.